Section 1. Seeing and Speaking, the AI that powers our world. Have you ever wondered how your phone knows it's you just by looking at your face? Or how a website can instantly translate a foreign language into your own? It might seem like magic, but it's not. It's science. Specifically, it's a field of science called artificial intelligence, or AI. Two of the most incredible parts of AI are computer vision natural language processing, also known as NLP. In very simple terms, computer vision is all about teaching computers how to see and understand the visual world, just like our eyes do. And NLP is about teaching computers how to understand, interpret, and generate human language, just like our brains do when we read, write, and speak. These amazing technologies are all around us, working quietly in the background to make our lives easier, safer, and more connected. They are the brains behind self-driving cars that see the road ahead, and the smart assistants in our homes that understand our spoken commands. They are not just gadgets for fun, they are powerful tools that are changing everything. Section 2. How computers learn to see. A world of pixels and patterns. Let's start with sight. How does a computer see a picture? Well, for a computer, a picture isn't a single thing, it's a giant grid of tiny dots called pixels. Imagine a huge checkerboard where every single square has a specific color. A computer sees this picture as a massive list of numbers. Each number tells the computer the exact color and brightness of one single pixel. To you, it's a picture of a dog. To the computer, it's millions of numbers arranged in a grid. The challenge for computer vision is to teach the machine how to find the dog pattern within that sea of numbers. To do this, scientists came up with a brilliant idea inspired by our own brain's visual cortex. They created something called a convolutional neural network, or CNN for short. You can think of a CNN as a stack of special magnifying glasses, each designed to find a specific feature. The first layer of the CNN might have simple magnifying glasses that look for basic things: straight edges, corners, simple color blobs. These are called filters. A filter is a tiny window, maybe 3 by 3 pixels wide, that slides across the entire image, pixel by pixel, looking for its assigned pattern. Section 3. How computers learn to read. A symphony of words and meanings. Now, let's switch from seeing to reading. How does a computer understand language? Unlike a picture, text doesn't come in a neat grid of pixels, it comes as a sequence of words. The first step in NLP is to break a sentence down into smaller pieces, called tokens. A token can be a whole word, like cat, or even part of a word, like ing. Once we have these tokens, we have to turn them into numbers that a computer can work with. This is done using a technique called embedding. And embedding turns each token into a long list of numbers called a vector. Think of it as giving each word a unique coordinate in a giant, multi-dimensional meaning map. On this map, words with similar meanings are placed close together. Modern NLP models, especially the powerful ones called transformers, use a special mechanism called attention. Attention allows the model to weigh the importance of different words in a sentence when it's trying to understand a specific part of it. Consider the sentence. The bee landed on the flower because it had nectar. Section 4. From code to real life. Vision and language in action. So these complex systems of filters and attention mechanisms are fascinating, but where do we actually see them in our daily lives? The applications are everywhere, and they are more common than you might think. Let's start with computer vision. The face unlock feature on your smartphone is a perfect example. When you set it up, a model analyzes your face and creates a unique mathematical template of your key features. In the world of manufacturing, computer vision acts as a tireless quality inspector. Imagine a factory producing thousands of soda bottles every hour. A camera positioned over the conveyor belt takes pictures of each bottle. Now let's turn to NLP. Have you ever used a customer service chatbot on a website? When you type a question like, "Where is my order?" an NLP model gets to work. It first identifies the intent of your question. In this case, order status. Another powerful use of NLP is in language translation. Services like Google Translate use massive transformer models that have been trained on billions of sentences translated by humans. This allows us to break down language barriers. Section 5. The big picture, what we learned today. So, let's zoom out and look at the big picture. Computer vision, natural language processing. We learned that computer vision gives machines the power of sight, allowing them to interpret the world from images and videos. We saw that this is often done using convolutional neural networks, or CNNs. They act like a series of filters that learn to recognize patterns, simple edges, a face, a car. We also dove into the world of natural language processing, which gives computers the ability to understand and generate human language. We discovered that modern NLP relies on powerful models like transformers. Both fields, vision and language, share a common foundation. They learn from vast amounts of data. From unlocking your phone with a glance to getting an instant summary of a long article, these technologies are no longer just science fiction. They are practical tools woven into the fabric of our modern world, making our devices smarter and our lives more convenient. If this has sparked your curiosity, and you want to learn more, you don't need to become a computer scientist overnight. Consider it